Problem 34. This is the most challenging problem. Water, oil, and air are present in the cylindrical tank as shown. Determine the maximum pressure that can develop within the tank, the force exerted by the fluids on the circular end of the tank, and the location of the total force on the side of the tank from the interface between air and oil in meters. So this is the given figure. We have air under pressure 20 kilopascals. Then this is 0.3. This is the circular end. We have oil in contact and on the lower half water. For the maximum pressure, it occurs at the bottom. So we sum up pressure from this interface here down to the bottom. So beginning with 20 plus 0.8 times 9.81 times 0.9 or 0.3 plus 0.6, then plus 9.81 times 0.6 equals maximum pressure which occurs at the bottom. So the maximum pressure is equal to 32.95 kilopascals. The force exerted by the fluids in the circular end of the tank. So we have force of oil in the upper half, force of water in the lower half. So to analyze, self-analyze, let's enlarge that end and let's locate the centroid and the center of pressure. So at the center of pressure acts FO here, F water here. So the distance from centroid to the diameter is 4r over 3 pi, 4 times 0.6 over 3 pi, and this is also 4 times 0.6 over 3 pi. Then the distance between centroid of the upper half and of the semicircle and the center of pressure of the upper half where force of oil acts is EVO. Then this one is EV of water. So let's use FO equals pressure at the centroid of oil, then area of the semicircle. So F equals FO plus F of water. FO equals pressure at the centroid of oil times area of oil, which is semicircle. Same is true with the water. Now, beginning with 20, the pressure at the centroid of oil is 20 plus 0.8 times 9.81 times quantity 0.9 minus 4r over 3 pi. So FO is 20 plus 0.8 times 9.81 quantity 0.9 minus 4r over 3 pi. Because at the diameter it is the depth of oil is 0.9, then we have to go up to the centroid. So we have to subtract 4r over 3 pi because this is the centroid. So the distance from the interface of air and oil to the centroid of oil is 0.9 minus 4r over 3 pi. And this is the area. Before computing FO, let's compute for the pressure because we need this in computing EVO later. So the pressure at the centroid of oil is 25.065 kilopascals. And this is the area of semicircle. 0.5 pi the radius square. So FO is 14.174 kilonewtons. Then for water, pressure at the centroid of water is 20 plus 0.89.81 times 0.9 plus 9.81 times 4r over 3 pi. So take note that the distance from diameter to centroid of the lower half is 4r over 3 pi. So F of water is pressure at the centroid of water, area of semicircle, again, area of water. So it is 20 plus 0.8 times 9.81 times 0.9 plus 9.81 times 4r over 3 pi. So we go down by 4r over 3 pi from here. And that is already water. Then area 0.5 pi 0.6 square. So again, let's compute for the pressure at the centroid of water before computing the force. It is 29.561 kilopascals times area of the lower half pi over 2 or 0.5 pi 0.6 square. So it is 16.717 kilonewtons. Then F on the circular end is FO plus F of water. 14.174 FO plus 16.717 F water. So it is equal to 30.89 kilonewtons. Then the location. So this is the center of pressure of the circular end. This is the force 30.89 kilonewton acts. Then its distance from the air-oil interface is 0.3 from the top. Then this is 0.6. So 0.9 to the diameter. Then let's call it 8 sub Cp. Let's find 8 sub Cp. So this is the equation by Varignon's theorem. F times 8 sub Cp equals Fo times moment arm of Fo. Fo is acting here, so its moment arm is 0.9, then minus 4r over 3 pi, it's now at the centroid, then plus EVO, plus F of water, distance or moment arm, F of water acts here, is 0.9 plus 4r over 3 pi plus EVW. So F water 0.9 plus 4r over 3 pi plus E sub VW, or E sub water. So 25.065 equals F equals pressure at the centroid of oil, which is 25.065 equals specific weight of oil, because it is oil that is in contact with the upper half, times barred H of oil. So barred H of oil is 3.194 meters. Then pressure at the centroid of water, 29.561 equals specific weight of water times barred H of water. Barred H of water is 3.013 meters. Then the formula for EV for semicircle is 0.0699 R square over barred H. But let's derive it again. It is I sub CG 0.1098 R to the fourth over area 0.5 pi R square semicircle times barred H. So 0.1098 over 0.5 pi, it reduces to 0.0699 R square over barred H. So EV of oil is equal to 0.0699 times 0.6 square over 3 times over 3.194 barred H of oil. So it is equal to 0.007879 meter, while E sub V of water is equal to 0.0699 0.6 square over 3.013. So it is equal to 0.008352 meters. Then substitute in our working equation, which is this. So 30.89 times 8 sub Cp equals 14.174, quantity 0.9 minus 4.6 over 3 pi plus EVO, which is 0.007879. Then plus F water 16.717 times quantity 0.9 plus 4 times 0.6 over 3 pi plus E sub VW, which is 0.008352. So using your calculator there, we can now compute 8 sub Cp equal to 0.9291 meters. So that's it for this problem. This is the last example for vertical surfaces. Next would be inclined surfaces, still arranged from basic to challenging. Just like this is the most challenging problem on vertical plane surface.